Good afternoon, dear students. In this class, we are going to discuss about alkaline earth metals. Alkaline earth metals are they are group 2 metals. So, what are the elements are present in group 2 metals? Beryllium, magnesium, calcium, strontium, barium, and radium. These 6 elements are generally called alkaline earth metals or 2s group metals. From these 6 metals, beryllium, magnesium, calcium, strontium, barium, and radium. These metals are generally known as alkaline earth metals. From these 6 metals, beryllium has some specific quality or distinctive property. They have some distinctive property like lithium in the first group elements. In the first group, lithium have some distinctive properties, right? So like the second group elements, beryllium also a distinctive one from the other alkaline earth metals. Because of this distinctive property, these other elements that means magnesium, calcium, strontium, barium, and radium, they are commonly known as alkaline earth metals. But we have some exception because beryllium is distinctive one. Okay, so beryllium are commonly not included with the alkaline earth metals. If we say this alkaline earth metals means magnesium, calcium, strontium, barium, and radium. Why it is not called beryllium is not called the alkaline earth metals? Because the oxide and hydroxide of other alkaline earth metals, they have the nature is basic in nature. That means alkaline nature. Alkaline in nature. Their oxides and hydroxides. But beryllium oxide and hydroxide not in alkaline nature. These metal oxides are found from earth crust. Like ore, from the earth crust we extracted the metals from ore and minerals. Look at the table 5.7. Here they are given the mineral sources with the abundance in earth crust. So element beryllium 2.0 ppm and the mineral source is beryl, and magnesium 27,640 ppm. Their source is carnallite and dolomite. Then calcium, their formula they are given here, beryl, and this is carnallite, this is dolomite. And third one is calcium. In calcium is present in our earth crust by abundance 1.84 ppm, and the name of the source is fluoropatite. So formula of that fluoropatite is given here, and strontium is present in our earth crust 384 ppm, and name of that source is celestite, and formula is given in here. And last one, barium, it's present in our earth crust 390 ppm, and the source of this barium is barytes, is given here. That means barium sulfate. General characters of alkaline earth metals. Generally, these alkaline earth metals are occur from the earth crust, and we already learned this abundance of this alkaline metal source in the earth crust. So from this list, beryllium is a rare element from this alkaline earth metals. Beryllium is a rare element. And last element from this list is radium. So radium, we know that radium is the rarest element and this is a radioactive element. And this rare element and rarest element are comprising only in 10% of igneous rocks. Only in the 10% of igneous rocks. From this list, magnesium and calcium are the common elements from the earth crust, and calcium is fifth most abundant element. Calcium, fifth most. Fifth most abundant element. Magnesium is eighth most abundant element. So magnesium and calcium both are abundant elements, are most common element from this alkaline earth metals, and we can occur this most abundantly from the earth crust. And we got the element like the ore. Magnesium ore is occur from the source or from the earth crust is carnallite, in the form of carnallite and magnesite and dolomite. Then the calcium is occur from the earth in the form of chalk, limestone and gypsum. Gypsum is also a ore of this calcium. And strontium is the next element. This strontium is found from the earth crust as a mineral, celestite and strontianite. So these two form, strontium is present in our earth crust. And barium is the less common element. Less common element, and we got this from the form of minerals is barite. Radium, you know that radium is a rarest element from this alkaline earth metal, and also it is a radioactive element. It can produce the decay product. It can be produced from the decay product of uranium. So uranium, so we can occur this from the uranium bearing ores. Uranium bearing ores. This is the physical state of this alkaline earth metal. First, general character. Physical state. So physical state of alkaline earth metals, mostly they are found from the earth crust as a from the minerals. We can occur it from the minerals. Next general character is electronic configuration. So electronic configuration, you know that electronic configuration, we have two electron in the valence shell, the outermost valence shell of this second group elements. Commonly they are ns2. For first group element, that is ns1. Here it is ns2. That means addition of one more electron from the in the valence shell. So the common electronic configuration for this group 2 is ns2, and the electronic configuration for this alkaline earth metals, first beryllium 4, magnesium, then calcium, strontium, barium and radium. So write the atomic number for this: beryllium 4, magnesium 12, calcium 20, strontium 38, barium 56, and radium is 88. So we are going to write the electronic configuration for this elements are: first helium. This is noble gas electronic configuration in the form of noble gas. So helium. So what is the number of helium? It is 2. Okay, so 2, then 2s2, 2s2. Then write the electronic configuration for magnesium, neon, put this in bracket, and write the electronic configuration here. It is 10 and 3s2. Okay, totally 12. Likewise, you have to write the electronic configuration. So electronic configuration for calcium is argon 4s2. Then here it is krypton 5s2. Then xenon 6s2. Then radon 7s2. Okay, so this is the electronic configuration. These are the electronic configuration for alkaline earth metals. So from this electronic configuration, to donate 2 electron to the another elements to form the they can attain the noble gas electronic configuration. That means stable electronic configuration. The next character is atomic and ionic radii. Atomic radii. So atomic and ionic radii of alkaline earth metals are smaller, or it is lesser than the alkali metals. So group 2 electrons size are lesser, or the atomic size are lesser than group 1 metals. Why? Because of the high nuclear charge is present in group 2, high nuclear charge in the group 2. This high nuclear charge, so the charge which is present in the nucleus is attracting the electron from the orbit. So because of the strong electrostatic force, or the strong attractive force from the nucleus, these electrons are attracting by nucleus. So because of this high nuclear charge, the size of atom is going lesser, or they are decreasing from top to bottom of the group. So the radii is increasing when from the top to bottom of the group. So gradually the number of shell is increasing. So the screening effect also it is increasing. So the radius is increasing when come from top to bottom of the group 2 elements in the modern periodic table. Next general character is oxidation number or oxidation state. So what is the oxidation state for this alkaline earth metals? You know that for the alkali metals it is +1. So for alkaline earth metals, common oxidation number is +2. Why? Because of the outer shell of your alkaline earth metals contain 2 electrons. So we can easily remove these 2 electrons without any trouble. So we can easily remove, or it can easily donate the electron, these 2 electrons. After releasing or donating this electron from these metals, this element will attain the noble gas electronic configuration. So that is very difficult to remove the electron from the noble gases. Because of that noble gas electronic configuration attaining, this alkaline earth metals have oxidation number, common oxidation number is +2. Next general character is ionization enthalpy. Ionization enthalpy is the minimum amount of energy required to remove the electron from the particular element. So when compare this ionization enthalpy of alkaline earth metals with p block elements, this alkaline earth metals have larger size. So because of this large size, the ionization enthalpy is very low than the p block elements. So the large size means their nuclear charge, the attractive force from the nucleus is less than the more force element. So here we can easily remove the electron from the outermost shell. Because of that ease of removing electron from the valence shell, it can attain the low ionization enthalpy than B block elements. So the ionization enthalpy is less, low ionization enthalpy, because of the size, larger size. So when you move from top to bottom, when you move down to the group of that alkaline earth metals, size is increasing. So ionization enthalpy is decreasing. So gradually increasing the size, it is decreasing ionization enthalpy in group 2 element. Why? Because of number of shell is increasing. So because of increasing the number of new shell, and also it is increasing the screening effect. Okay, so because of this size and screening effect, then the number of shell in alkaline earth metals, this ionization energy is decreasing when moved from top to bottom of group 2. So comparing this group 1 with group 2, which one is larger size? Group 2 is getting larger size than the group 1. This is smaller size. Compare these two groups. This is smaller and this is larger size. So because of the ionization, the atomic radii and ionic radii of this group 1 and group 2, group 1 is smaller ionic atomic radius and ionic radius. So in the group 1, group 2 elements members, that means elements have higher ionization enthalpy than the group 1 elements. Group 2 have higher ionization enthalpy than the group 1 elements. So the variation of ionization energy of alkaline earth metals is given in this graph. Ionization energy, atomic number. So atomic number is increasing, ionization energy is increasing. When we plot this magnesium, calcium, strontium, barium and radium, in this we can get the value 899. Here it is 700. So it is decreasing the ionization energy. Why? Because of the size is increasing from top to bottom. So magnesium is smaller than calcium. Calcium is smaller than strontium. Strontium is smaller than barium. Barium is smaller than radium. So because of this size, increasing the size from when come top to bottom of group 2, because of that ionization energy is decreasing in group 2 top to bottom. So anyway, the first ionization energy of the alkaline earth metals is higher than the alkali earth metals. Why? Because the outermost shell or the general electronic configuration, the valence shell NS2. So they completely filled one orbital. Because of this completely filling electron in this orbital, they we need more energy to remove the electron from this orbital. Because of that, this ionization energy, first ionization energy of alkaline earth metals are larger than the alkali earth metals. Comparing this first ionization energy of alkali earth metals, general electronic configuration is the NS1. So they filled only one electron in this orbital. This is not completely filled. So we can easily remove this one electron. So we require only less energy of ionization energy to remove this electron. So they need more energy than this energy. So because of that, first ionization energy is greater than it is greater in alkaline earth metals. When we look at the ionization energy, second ionization energy of this alkaline earth metals, this is alkaline earth metals, this is alkali metals. So when the alkali earth metals, you can get the noble gas electronic configuration like helium or neon. Okay, so this noble gas electronic configuration need more energy to remove the electron, because that is fully filled orbitals. Okay, they contain only fully filled orbital. So because of that, the ionization energy of the second ionization energy of alkali metal is, it need more energy to remove the electron, but it is difficult. Okay, so in the second ionization energy of alkaline earth metals need only some energy of removing one electron, because that is loosely bound electron from this orbital. Okay, so we can easily remove this. So comparing this second ionization energy of alkali earth metals and alkaline metals, alkali metals are greater second ionization energy than the alkaline earth metals. So alkali metals are greater ionization, second ionization energy than alkaline earth metals. Next character is hydration enthalpies. Hydration enthalpy, you know that dissolving the metal into water. So the ability of element to dissolve in the water is hydration enthalpy. So alkaline earth metals are more extensive hydrating than the alkali metals. So because of this hydrated compound of alkaline earth metals are larger one than the alkali metals, because they dissolve in it and they get the water compound, they attach with the water compound from the water. So hydration enthalpy of this alkaline earth metals are decreasing when moved from top to bottom. That means increasing the size of atom with decreasing hydration enthalpy of an atom. So the series of this hydration enthalpy, beryllium is smaller size compared to magnesium, calcium, strontium, barium and radium. So here radium is a radioactive element, so we neglect that one. So see this one, beryllium, magnesium, calcium, strontium and barium. So beryllium is smaller size than magnesium. So magnesium is smaller than calcium, calcium is smaller than strontium, strontium is smaller than barium. So because of this size decreasing So increasing the size. Size is increasing. Size is increasing here. Size increasing. So size increasing means decreasing hydration enthalpy. Decreasing hydration enthalpy. So shall we write this one? So beryllium is greater hydration enthalpy than magnesium. Magnesium is greater hydration enthalpy than calcium. Calcium is greater hydration enthalpy than strontium. Strontium is greater hydration enthalpy than barium. Okay. So this is the series of hydration enthalpy. Next character is electronegativity. You know that this is an electropositive compound. It's di-electropositive compound. So because of that, due to this high electropositivity, electronegativity is decreasing top to bottom of the group, decreasing. Next character, flame color and spectra. Flame color and spectra. The elements are mixed with the concentrated hydrochloric acid. Then it's shown heating in the platinum wire in the flame. Okay, in the flame we are heating that solution element with concentrated hydrochloric acid. Element with concentrated hydrochloric acid. This paste took in platinum wire and shown this to flame. Because of the mixture of this concentrated or moistened element, moistened alkaline earth metals, it has some ability to show the coloring or some in the particular spectrum. They can show some color. The flame color in the visible region is given the alkaline earth metals flame color. Calcium, the paste of this concentrated hydrochloric acid calcium is shown in the flame, and it shows the flame color is brick red color. So the wavelength in the visible region 622 nanometer. In the strontium, it's shown crimson red color in the flame, and in the visible region 689 nanometer. And in the barium, moistened barium is shown in the flame with the platinum wire. It can show the color apple green color, and under the visible region 554 nanometer. So when we heat this flame or the moistened paste with the flame, they can excite. Okay, they are exciting because of the heating. The solution or the element get excited, and the valence electron which is present, they are moving into the excited state. When we remove or draw back this heat, this the electron which is going into the excited state, they can also they will become, or they will back to the actual stage or the ground stage. So when the exciting state moving the electron from the ground state to the excited state, moving electron from ground state to the excited state, they emit some energy. So that energy in the form of light. So they can show this in the wavelength of visible region. So because of this light, we can measure that wavelength in the visible region. Already we learned that table, that color and wavelength, big red color, crimson and apple green color for this calcium, strontium and barium in the wavelength. So we are calculated from this method. Okay students, today's topic over. Thank you students.